So for my project, I did a parallel wound motor. As you can see, the armature and the field coil are both in parallel. The power supply is 2D batteries. They are in parallel with each other. To make the armature, I simply wrap the wire around in this counterclockwise direction as you're looking at it, and then it leaves this way. And to make the commutator on the armature, I simply stripped off, I guess, the bottom half, so where my finger is, the insulation off the wire on that side, so this bottom half. To make the field coil, all I did was I wrapped the wire around this little bobbin, and I went around in this direction, which I guess is clockwise as you see it. So it's going, the windings are going over around the top. And I chose to use this bobbin because it was easy to wrap the wire around, and the steel used to make the bobbin has a pretty decent permeability, so it improved the strength of this magnet. When looking at this, the diagram for this motor and its forward polarity, so as I just showed it to you, you can see the current comes here. It's going to flow into this armature. It's going to flow in the direction shown by that current arrow there, and it's also going to flow into the field winding, and it's going to flow in the direction shown by here, doing the second right-hand rule by Ampere's law, where my fingers represent the current and my thumb represents the flux density. You can see that the flux density is pointed out, and then you could take your cube and you can do the first right-hand rule by Faraday's law, where current's pointing that way, flux density is pointing out, and you can see you get an upward force. I predicted that this upward force would want to turn the motor in this clockwise direction. So if we look at our motor and we turn it on in the forward polarity mode, and we'll see if that's right, and give it a little spin, and there you go. You can see the motor is spinning in that clockwise direction. So my theory was correct. Now if we reverse the polarity, we can look at this diagram here, and you can see that now the current's going to go this way. It's going to flow in the armature here. It's going to go in the direction shown by that arrow, and then it's flowing out. And then when it comes to the field coil, it's going to flow in here, go around in that direction as shown, and then also flow out. And due to the second right-hand rule by Ampere's law again, you can see that now the flux density is pointing towards the batteries. And then we get our cube, and we to use the first right-hand rule by Faraday's law, where the current's going that way, now the flux density is going out, and you can see the force is still up again. And I predicted that this would also want to rotate in a clockwise rotation, as shown right here. And so now I got another set of D batteries here. There's the plus side. This is the same power sources here. And we're just going to reverse the polarity. And we're going to give a spin. And you can... There it goes. It's spinning in the clockwise direction again, just like it did before. So this shows you that in this parallel motor, it doesn't matter if you reverse the direction of the polarity, because the two windings are in parallel with each other. When the current's reversed, the flux density is reversed, but since the current and the flux density reverse, the direction of the motor remains the same. So this is my parallel wound DC motor.